I've been hearing a lot about Amazon Elastic MapReduce. I hear you can use it to process and gain insights from large amounts of data.
You can. Amazon Elastic MapReduce gives you the ability to process or warehouse large amounts of data without the need to buy or manage hardware. It gives you the ability to easily launch, scale, and manage Apache Hadoop clusters on Amazon Web Services. And you can quickly leverage the large ecosystem of tools and applications in the Hadoop ecosystem.
So how does it work?
Amazon EMR provides a managed framework to easily create, customize, and use Hadoop clusters created with Amazon Elastic Compute Cloud instances. Amazon EMR also has tight integration with other Amazon Web Services, like Amazon Simple Storage Service, where you can store both input and output data for your Amazon EMR cluster.
Guess I should learn more about Amazon EC2 and Amazon S3.
Well, Amazon EMR takes much of the complexity out of managing your own cluster of Amazon EC2 instances. But if you would still like to learn more about these services, there is free introductory training on YouTube with a free self-paced lab.
Do I need to worry about setting up hardware or installing, running, and tuning Hadoop?
No, Amazon EMR takes care of that so you can focus on the analysis of your data instead of managing your infrastructure and software.
Can I add more nodes to my cluster if I want to process larger volumes of data?
Yes, you can easily expand or shrink your cluster by adding or removing Amazon EC2 nodes to match the size of your cluster with your current needs. And if you store data in Amazon S3, it can be accessed by multiple Amazon EMR clusters to run separate workloads simultaneously.
Very cool. So this means you can quickly set up as many clusters as you need to test new ideas, and then terminate the clusters when you no longer need them.
Exactly. This helps you speed up innovation and lower the cost of experimentation. Plus, you only pay for what you use.
Besides MapReduce, what other applications can I run on my Amazon EMR cluster?
It is easy to use a variety of powerful programs in the Hadoop ecosystem on your cluster, like Apache Hive and Pig, which use higher-level languages like HiveQL, SQL, and Pig Latin to create MapReduce jobs, making it simpler to submit jobs and queries. AWS even provides code samples and tutorials to help.
How do I access Amazon EMR?
You can access Amazon EMR via the AWS Management Console, command line, or SDK. For the AWS Management Console, let me log into my account and show you what it looks like and how easy it is to create, launch, and monitor a cluster. At the AWS Management Console homepage, click the Amazon S3 icon to store the input into the cluster and to receive the output from the cluster. You can also optionally use the Amazon S3 bucket to back up the Hadoop log files generated by the cluster so you can inspect them after the cluster ends. Click Create Bucket. Enter a unique bucket name and select a region. To avoid paying cross-region bandwidth charges, create the Amazon S3 bucket in the same region as the cluster you'll launch in Launch the Cluster. Click Create. For this demo, we will need two folders inside this bucket. One for output, one for logs. The next step is to launch the cluster. When you do, Amazon EMR provisions Amazon EC2 instances, virtual servers, to perform the computation. These Amazon EC2 instances are preloaded with an Amazon machine image that has been customized for Amazon EMR and is preloaded with Hadoop and other big data applications. Go back to the AWS Management Console home and open Amazon Elastic MapReduce by clicking on the icon. Click Create Cluster. On the Create Cluster page, click Configure Sample Application. The Configure Sample Application dialog box opens up. Choose word count from the Select Sample Application drop-down menu. In the Output Location field, type the path of an Amazon S3 bucket to store your output. Leave the logging option selected. And add your new bucket and log file as shown below. Deselect the debugging option. Click OK to move on and go back to the cluster configuration page. On the cluster configuration section, add a cluster name. This is optional and it doesn't need to be unique. If not already selected, choose Yes to enable termination protection, which ensures that the cluster does not shut down due to accident or error. If not already selected, choose Enabled for logging to determine whether Amazon EMR captures detailed log data to Amazon S3. Keep the rest of the cluster configuration at default settings. Under Tags for the Key column, type Owner. For the Value column, type Development. In the Software Configuration section, choose Amazon to determine which distribution of Hadoop to run on your cluster. You can choose to run the Amazon distribution of Hadoop or one of several MapR distributions. Choose 2.4.2, Hadoop 1.0.3 for the AMI version. This determines the version of Hadoop and other applications such as Hive or Pig to run on your cluster. In the Hardware Configuration section, leave the network in VPC. This is the Virtual Private Cloud. We will not be creating a new Amazon EC2 subnet, so leave that option set to No Preference. For master, choose M1 small. The master node assigns Hadoop tasks to core and task nodes and monitors their status. There's always one master node in each cluster. For this demo, we are going to leave the Request Spot Instances box unchecked. Choose M1 small for core. A core node is an Amazon EC2 instance that runs Hadoop map and reduce tasks and stores data using the Hadoop Distributed File System, HDFS. Core nodes are managed by the master node. Keep 2 for the count, and again leave the Request Spot Instance box unchecked. Task should be M1 small, and count should be 0. Keep the last Request Spot Instances box unchecked. For the purpose of this demo, we will leave the security and access section values as is. It is a best practice to choose an Amazon EC2 key pair from the list. If you do not enter a value in this field, you cannot use SSH to connect to the master node. In the Bootstrap Actions section, there are no Bootstrap actions necessary for this sample configuration. In the Steps section, note the step that Amazon EMR configured for you by choosing this sample application. You can modify these settings to meet your needs. Review your configuration, and if you are satisfied with the settings, click Create Cluster. When the cluster starts, you see the Cluster Details page.
Very cool.
Next, Amazon EMR begins to count the words in the text of the CIA World Factbook, which is pre-configured in an Amazon S3 bucket as the input data. When the cluster is finished processing the data, Amazon EMR copies the word count results into the output Amazon S3 bucket that you chose in the previous steps. Let's take a look at the Cluster Details page while the job is running. In this example, the cluster is performing the work defined by the word count application. Expand the Monitoring section to see metrics about the cluster. These metrics are also reported to Amazon CloudWatch and can also be viewed from the CloudWatch console. The chart tracks number of jobs the cluster is running, status of each node in the cluster, to name a few. In the Steps section, you can see details about each step in the cluster. After the cluster is complete, the results of the word frequency count are stored in the folder you specified on Amazon S3 when you launched the cluster. From the Amazon S3 console, select the bucket you created. You will see a success file. Once a folder or object is selected, you can click Actions or do a right-click to open, download, and delete that item. Congratulations! You have successfully deployed an Amazon Elastic MapReduce cluster and processed some data.
Thanks. Now I want to get started with the free training.
Go to run.quicklabs.com to try it out with a free self-paced lab. While you're there, check out the other free AWS introduction trainings to learn about more AWS products and services. You can play around without having to open an account.